So good morning everyone. We have already discussed what is meant by linked list. Now we are going to talk about the types of linked list. Before proceed, let's see all the types, then we will see one by one. Okay. So linked lists are categorized into different types such as single linked list, doubly linked list, or double linked list, circular linked list, and circular doubly linked list. Out of these, singly linked list, doubly linked list, and circular linked list, that is what we are going to discuss in detail. Okay, so let's talk about one by one. Singly linked list. What is meant by singly linked list or single linked list? A single linked list is one. A single linked list is one in which all nodes are linked together in some sequential manner. In some sequential manner. How it is? Let's say we have one node of the linked list, then we have second node of the linked list, then we have third node of the linked list. So these are the nodes, and the concept is nodes are linked together in some sequential manner. So how is the sequential manner? After node 1 we have node 2, after node 2 we have node 3. So in only forward direction, the links are only in forward direction. This kind of linked list is called as singly linked list or single linked list. A linked list allocates space for each element separately in its own block of memory called as node. So whatever linked list we have, it allocates space for each element in its own block of memory, and we call it as a node. The list gets an overall structure by using pointers to connect all its nodes together like a links in the chain. As I have shown here in the diagram, in this we can see that these are the node, and node 1 has the address of the node 2, node 2 will have address of the node 3, and the last node will be pointing to null value because this is the last node of the linked list. Okay, so here this overall structure uses the pointer. What is this? This is the pointer which holds the address of the next node. Okay, that's why we are saying that the overall structure, the link gets an overall structure by using pointers to connect all its nodes together. So through pointers we connect all nodes together. Okay, why? Because pointer holds address of the next node. Okay, each node, now we know that each node of the linked list contains two fields. Each nodes of the linked list contain two fields. A data field which stores whatever element is or whatever item is. So item or element is stored in the data field of the node, and another is called as next field or next pointer field, which is a pointer used to link to the next node, or which is the pointer used to hold address of the next node. Hold address of the next node. Each node is allocated in heap memory using malloc function. See, when we create the node, that is just creation of the node. We need to allocate memory to that node so that data can be stored in that particular node. So that can be done by using a malloc function. So each node is allocated in heap memory using malloc function. So the node memory continue to exist until it is explicitly deallocated using free. So heap memory, whatever heap memory we have, it persists after end of the program also. So what we need to do, if we want to reclaim or if we want to make that used memory free, then we have to use the function free. We have seen in last lecture itself, malloc and free function. So explicitly we have to use free function so that the memory allocated to that node will be released, and that can be used for other purposes. The front of the list is pointer to the start node. I have already told you that the first node of the linked list we are going to call as a head of the linked list, and that is nothing but the first node. Fine. The beginning of the linked list is stored in a start or head pointer. In most of the books or reference books, either it is called as start node or head node. Both points to the first node of the linked list. Okay, which points to the first node of the linked list. The first node contains pointer to the second node. As I told you, the first node will have two parts. data part and the pointer field. That pointer field will contains address of the next node. When we create the next node, at that time only that node's address will be there in first node. Okay, I will show you how that happens. The second node contains pointer to the third node and so on. The last node, how to identify which is the last node of the linked list. So this is the answer. The last node in the linked list has next field set to null to mark the end of the list. So the node whose next pointer contains null value, the node whose next pointer contains the null value will be the last node in the linked list. Is this clear? Okay. Code can access any node in the list by starting at the start and following the next pointers. So whatever nodes we have, assuming that node 1, node 2, node 3 up to node n, we can access any node, but we have to start at the start node and then following the next pointer. So we will start from the first node. First node will contain address of the next node, that is second node. Second node will contain address of the next node, that is third node, and then we will proceed till the next of the node contains the null value. So when next pointer of any node will contain the null value, what it means? That is the last node of the linked list, and we will stop there. Okay. Now here I am showing you some in diagram, so let me do one thing. Okay, so this is the head or start node, this is the data part, this is the next pointer. Next pointer will contain the address of the second node, and then next pointer of the second node will contain address of the third node, and the last node's next pointer will contain the null value, and this is nothing but end of the linked list. Is this clear to everyone? Yes. Now we will talk about singly linked list implementation. How to implement a singly linked list. We have seen before this what? How to implement a node of the linked list. Okay, now we are going to talk about how to implement singly linked list, creating a structure. We know that we create the data structure. So what we are going to create? Creating a structure with one data item and the next pointer which will be pointing to next node of the list. This is called self-referential structure. So basically we are going to create a self-referential structure. Why self-referential? Because in the node definition I have shown you that the next pointer points to the same node. Points to the same node. That's why it is called as self-referential. Okay. So how to create a singly linked list? First we are going to create a structure. In that we are going to declare two data items. One will be data item and another will be the next pointer. Two fields will be there, same that we have seen. Then we will create a start node which will be used to create and access other nodes in the linked list. So initially we will begin with creating a start node. Then we will initialize the start pointer to be null. Start pointer to be null means initially if the start pointer is null, that means my linked list is empty. What it means? It means that my linked list is empty. Now see here, struct s linked list, that is singly linked list. S linked list means singly linked list. Int data, this is data item, and then struct singly linked list next pointer, self-referential pointer. So this is nothing but the way we are going to create a node for a singly linked list. Creating a node for a singly linked list. Now, node data next. So this is the data and this is the next pointer. Okay. Now we will initialize start as null. That means initially my list is empty. My linked list is empty. That's why start is initialized with null value. Okay.